transfer the grade for the other students. You want to just talk to it's already
We're seeing a lot of energy.
What, Bird?
Yeah.
Yeah.
What are you doing?
5.1.
Pretty good.
I think it's 10 to 18.
10 to 18.
There you go.
Okay, now me. Now me. I am aware there's a bird in the room. Sometimes birds make mistakes. This is a female house finch. She's probably a little panicked because she probably laid her eggs inside my fire alarm. And in flying away from her nest, she probably got spooked and took a right-hand turn and came into our classroom. And of course, in nature, flying uphill is a really good way for birds to get out of things. Of course, in buildings, that just slams them into the ceiling over and over again. It's kind of funny, kind of sad. Stupid little bird. She basically will either figure it out, not too likely, die of exhaustion, pretty likely, or the in-between road. She might get stressed out enough that her blood oxygen gets low and she'll start to drag ass and drop a little bit. And at that point, she'll go, oh wait. And because she'll be low enough, she'll fly straight out and exit. We can hope for that. There's some chance. Did you save my Tupperwares, Charles?
How often do birds?
Did you save my Tupperwares?
Yeah, but I'm letting you draw a little bit.
As often as they can.
Thanks.
Oh, okay.
No, but I think it's...
Yes.
How often do female house finches poop?
Do they what? Fly in here?
No, how often do they poop?
Oh, they poop pretty often. And by the way, I had meant to talk about that. The chances that she'll poop on someone with a class of this density are right around 100%.
Yay! We should play that's
I guess I don't want to spend all day talking about my poor little room guest. So suffice it to say that being pooped on by a bird is understandably kind of gross and everything, but it really is just bird poop, and as long as you didn't eat it, you would be 1,000% fine, and it washes off, and it really doesn't matter. So I know it sucks, and it's happened to me a trillion times, so I know it sucks, but... believe it or not, and I know that this will be kind of surprising to you, they're stressed out when you look at them, and they know when you're looking at them. You can imagine... I think everybody knows it's a very useful adaptation to sense when eyes are aimed at you.
Don't humans have that too? Can we detect eye contact and the football field away?
Exactly what Gately just said. Of course, we also have that. And we can tell if someone's looking at us or the person next to us from over 100 yards away. Notice how spectacular a feat that is. Try it sometime. It's really true. But yeah, how is it possible? Like, I don't know. It's basically, it's harder to see a human hair, like, you know, like this really, really, really fine difference.
Why you just suddenly get an urge to look at someone who's staring right at your eye?
So, imagine how stressed that thing is, knowing that it's about the size of our mouth. You and I know that we don't want to eat that bird, but the bird thinks we're all trying to eat it. And every time you look at it, her little stress level rises and her heart rate goes up. And let's not give her a heart attack. Let's just ignore the friggin' bird. Yeah. Does anybody still need to make up the Unit 9 exam? The Unit 10 plan is posted. Are there any questions about the Unit 10 plan? The following Ecotopia thieves are scum of the earth. That was false.
Yeah.
The following Ecotopia thieves are scum of the earth. Kitsa. No, known for being scum of the earth, obviously. Sarah. Likewise. Mackenzie Fell, as everyone knows, scum of the earth. Marlin Godless, lower than worms. Hugo has been redeemed like Darth Vader. After a life of evil, you can still do good, young man. I had to explain redemption to my 5-year-old. It was awesome. Marina, scum. Brianna, thief. Jake, so cute. Still a scumbag. Don't trust the cute ones. Maria, likewise, scum. Don't steal my books. Please bring them back someday. Yes, Gabby.
Yesterday said that you're sending anything on Thursday.
I lied. You mean it before yesterday? Oh, God. I don't want anybody to forget that this lab prep is due tomorrow. Friday. Just keep moving your toes, you know. Oh. Our after-school environmental film series is almost entirely over. The last movie is next week. But of the 2 showings that I've made available, we only have a parent for 1 next week. And the one that was planned for tonight has no parent, so I'm canceling it. Unless by some Hail Mary there's one of you available to have a parent for tonight at 6. Yes? There is a parent for tomorrow night. Next week we need a Wednesday. Talk to Ava Dore.
Sure, how long before I get tonight?
Will you confirm via text messaging? You get in touch with Ava, whose number I know you know?
Yeah.
I was going to say how long.
Maybe as a backup and get in touch with Ava as well, please. Just find out if she's available, and then we'll confirm, or Ava will confirm with her. Okay, so I guess we're on for tonight. Let me check with Ava. I think it's 6, but I'll see. Let's see here. Oh, Ava. Can you do 6 o'clock or 6:30? ASAP. All right, so I guess we're on for tonight, which is really good because tonight's movie is unbelievably good. The title is Red Gold. It's this movie, one of the first environmental documentaries sponsored by Patagonia about like a remote Alaskan fishing village that's conflicted about whether they should develop a gold and copper mine or whether they should preserve their salmon fishery. And if you're into fish or fishing or Alaska, the wildlife footage in this film is like heart-wrenching, like tear-jerking beautiful. Like, it is unbelievably spectacular. There's like clouds of giant Chinook salmon like flushing through shallow streams and like rugged, beautiful fly fishermen slaying them. And oh my God, it is such a spectacular film. Yeah.
My mom can.
Settled. So we're on for tonight, and the movie's called Red Gold, and it's really great, and I highly recommend it. It's one of the very few films in the series that I recommend to people outside of environmental science context. It's just beautiful. Oh, It screened at the Banff Mountain Film Festival a few years ago because it's just like eye candy for mountain types. It's not just about the environmental content. Oh, and the mine that it's about, called the Pebble Mine, has been in the news a lot because basically, like, right now it's being fought over by different political groups. Okay, Red Gold tonight. We should finish the movie, and then we'll do a little bit of 10.1. Are there any questions? Where did we leave off?
30.
What? 30? 31? 31 minutes.
Once through the
Sad, sad bird.
one problem.
You may extend that to the immediate family, and you may talk about.
So I guess this dude was talking about environmental crime or something? How weird it finishes? Imagine how relieved that bird will be when he finds himself out, when he puts himself outside. Okay, try not to watch her anymore. Good luck. Bye-bye. Oh, do you know about the Pebble Mine? So do you know that watershed?
I just feel like we need to think about that.
Hypothetical damage to society that a murderer exists and this violent act is occurring. But if you talk about contamination of the groundwater supply or poisoning the air, you can be talking about affecting thousands of people for 10, 20, or 30 years. That's a significant violent act against the society as a whole. And it is a crime.
The strike force has to cope with thousands of industries which handle an enormous variety of hazardous materials. But it's hard to know exactly what goes on down there. So this can never be the perfect solution to industrial waste problems.
It has become very expensive to do things correctly, to dispose of hazardous waste and to treat it or to recycle it. And as a consequence of that, I think you see an awful lot of mid-sized to small businesses that try to cut corners economically, that violate the criminal law.
There is an entirely different way to approach industrial waste, and it's worked successfully here in Denmark for 20 years. This is one of a national network of 21 government-run collection points for hazardous waste. Every factory has one within 30 miles. The only obligation? To make the delivery and report the contents. Although to be safe, samples are always taken for analysis. From here, the government ships the waste to a central treatment plant. The whole point is to make treatment as easy as dumping. This remarkable treatment scheme, probably the world's best hazardous waste handling system, has been running successfully for 20 years. It was sensible environmental thinking, not a Danish love canal, that inspired the program. Denmark's hazardous waste ends up in the small town of Nyborg. 20 years ago, local residents did not object to the idea. Nowadays, with so much more known about industrial waste, perhaps they would. But they can take comfort in the fact that the nearby plant is run as well as it could possibly be. When each shipment arrives, its contents are already known. That makes the first rule of hazardous waste treatment easy to follow. Different materials must be kept separate and handled individually, just like the garbage management in Japan.
Is Denmark just better at everything? Like, I don't know how, but they just seem to be, like, better at everything. Yeah. My grandfather's from Denmark. Was from Denmark. I've never met a person who had their game more together. Like, I never saw my grandfather. I lived in his house for years. I never once saw my grandfather with his hair not perfectly slicked back. Like, I don't know how he did it, but when my eyes were open, his hair was perfectly slicked back. Always wore an undershirt, always tucked his shirt. So had his game together, my God.
Narcotic drugs are included. Consumers simply have to return them to any pharmacy for them to end up here. The same applies to batteries and other household hazardous waste. Waste containing toxic heavy metals is chemically treated to produce a concentrated solid. This will be stored in a lined landfill, carefully mapped to allow later recovery. Manufacturers have to pay for their share of these expensive processes, so they've learned that waste treatment is a real cost.
Manufacturers pay for the waste disposal. Think about that one. Like, would Costco sell you a memory chip inside of like a Samsonite luggage case if they had to handle the waste disposal? They're like, whatever, bro, your problem. They just like crap in your house, and then you're like, okay, I'll clean it up. Thank you.
Program Manager Per Riemann.
In the beginning, many industries tend to forget that waste is costing money, and therefore they forgot about including the calculation, in their calculation for the products, that there is something called waste fees. Now we have tried to change that so that it's not a quite normal part of their calculation, that it's going in on equal level as water, labor, housing, and all that.
Organics like pesticides, waste oil, and paint go to the incinerators. Like Japan, they're properly run, and the emissions are scrubbed, so air pollution is negligible. And like Japan, the local people benefit. Half the town gets its home heating this way, and a new incinerator could soon provide electricity. Here the philosophy is that a well-run incinerator offers the least environmentally offensive solution to a problem that's not going to go away.
By using incineration, you are transferring the organics to water, principally water and carbon dioxide. By putting it on a landfill, it's just postponing the whole thing 20, 30 years so that our children can have the pleasure to deal with it in the future.
Incineration inevitably produces toxic ash, which must be landfilled, as in Japan. So even this well-run treatment system is not ideal. Far better is not to generate waste in the first place. And around the world, that's beginning to happen.
Literally, you can walk through any industrial activity, look around, and use common sense and see ways to immediately cut the generation of waste. And lots of chemical companies, what people have been doing, for example, is seeing how they use water. Enormous quantities of water are used to clean chemical equipment. That dirty water becomes toxic waste. If they use less water, or they replace water with mechanical techniques, ultrasound techniques, or just different subtle ways of cleaning equipment, they can immediately cut down on the generation of liquid hazardous waste.
Reducing waste at the source can be seen in action at this California factory, Aero Scientific, one of America's top 10 printed circuit board makers. Despite its clean image, this is not a clean industry. It uses extremely toxic materials. The boards themselves are etched with acids, dissolving heavy metals in the process. Where before, the metal and acid mixtures would have gone down the sewer, here, a recycling system neutralizes the acids, purifies 90% of the water for return to the plant, and recovers different metals for reuse or for sale as scrap. The system makes economic, environmental, and even managerial sense. Company President Sam Hughes.
Having the system allows us not to create the waste in the first place. It allows us to, it's easier to manage. If it runs that good, it's self-contained, we don't have spills, we don't have as much potential for spills. It's just easier to manage. We can spend our time doing other things instead of wrestling with that problem every day.
Waste reduction works well in this industry. In others, it may not. For the idea to spread, government intervention will be needed. Joel Hirschhorn.
Government has to make up its mind. whether we want industry to spend its money in the old-fashioned way, where they keep building end-of-pipe facilities to deal with the waste that they indeed produce, or does government want industry to spend its money on inventing and using clean technology so it doesn't produce pollution, so industry doesn't need the incinerators and the landfills and all the other facilities that deal with waste? That's a fundamental public policy view that quite has not been reconciled in the United States.
As developing countries industrialize, they too generate environmental pollution, from car exhausts to toxic waste. The sad truth is that high-tech waste treatment systems are often beyond the reach of these countries. In the last 50 years, Lima, Peru has swelled from 600,000 to a population of 7 million. Even basic services have not kept up. In the cluster of shanty towns that surround the urban center, garbage collection is not readily available. Water is not piped to most of the city. Instead, a water truck visits the barrio daily. The amount delivered to each family is a mere half gallon per person per day, to cover everything from washing to drinking. In an industrialized country, one person uses 50 times as much. Most of Lima's sewage is discharged untreated into the Pacific Ocean through a series of open sewers snaking through the area. One sewer passes through Acapulco, a shanty town on the coast, which its founders hoped would one day be as attractive as the Mexican resort. This Acapulco sewer joins up with a major drain nearby. The drain runs through one of the few open spaces available as a playground. In spite of the serious health hazard, local children find the water irresistible. Town Councilor Justino Torres Rio.
The children swim in this water, especially in the summer, because they don't have access to the ocean. The consequence of this contamination is the spread of typhoid, scabies, and funguses, all kinds of illnesses. We have gone to the authorities, but so far we have not found solution.
In contrast, most industrial countries treat their sewage using complicated plants like this. It's a typical installation using an array of chemicals and a battery of tanks, pipes, and pumps. When it comes in, the raw sewage is first held in settling tanks, normally kept covered to minimize both health risks and smell.
How many of you went to the wastewater treatment facility with me this year? Okay.
62 million gallons of sewage a day are handled here, from a town of about 500,000. The standard treatment process is explained by engineering professor Bob Gerhardt.
The first phase of conventional wastewater treatment is primary treatment. It's a physical process relying on gravity. The solids are separated from the liquid. The liquid goes on to subsequent treatment. The solids are taken onto methane digestion, a fermentation process.
The digester tanks greatly speed up natural processes, which use microorganisms to break down waste, like on the bottom of a pond, for example. Most of the sludge produced in the tanks is then discarded in a landfill. Meanwhile, these aeration units handle the liquid part of the sewage. This mimics another natural process in which other microorganisms consume dissolved organic material. Then, once the microorganisms have been removed, secondary treatment, as this is called, is complete.
At the end of secondary treatment, there is a physical process called the secondary clarifier. In this process, those beneficial microorganisms are settled, recycled, and reused in the aeration unit. As you can see, the water is pretty clean at this point. In the United States and most of the developed world, this would be considered the end of wastewater treatment.
Most places chlorinate the water just before discharge, but here they use more chemicals and filtration in an additional treatment stage. It produces a waste liquid close to drinking water standards. High-tech treatment like this is effective, if you can afford it, but it's energy and chemical intensive, and like garbage dumping, it wastes resources which sewage could provide. And it's beyond the means of 2/3 of the world, as Bob Gerhardt, who advises developing countries on the subject, has discovered.
It's uncommon to find waste treatment in developing countries because it's unaffordable to begin with. Part of the reason it's unaffordable is that the technologies that are being transferred by development organizations from various countries in the world and the engineers who are asked to implement those projects are totally inappropriate. They involve technologies that are expensive to build and expensive to operate and maintain.
But in one section of Lima, there's a sewage treatment system which offers none of these disadvantages. Based on this network of ponds, locally built and operated, it serves 100,000 people. The initial step is identical to the high-tech plant, simple screening out of objects that can't be biologically treated. But here, the similarity ends. The sewage is channeled to ponds in which two processes will happen. The solids fall to the bottom, where in the same pond, they'll slowly decompose. It's like combining the settling tanks and digester of the high-tech system in one location.
By the way, that's also how septic systems work, and by the way, I thought it would be obvious that you shouldn't be using your phones at this time being around.
The liquid moves on to ponds where algae grow. If conditions are maintained correctly, the natural photosynthesis will not only consume organic materials, but also produce wide changes in acidity, or pH. That's as good as chlorination, as manager Hugo Nava explains.
Photosynthesis, that is sun, will produce oxygen and consume CO2 during the day. During the night, it will release again the CO2 in the water. This consumption and releasing of CO2 will create a wide range of pH that could go from 10 during the day to 6 during the night. This variation in pH kills the bacteria and is the way we purify the water.
After 20 days, the water is safe to reuse. So, recently, they've added a third set of ponds to raise fish. Remaining organic nutrients support the growth of plants, which feed a hardy species called tilapia.
12.5, 15.9. By using a fish that can consume the phytoplankton that is produced in the tertiary pond, we can obtain a product that could be valuable for the community in terms of money or in terms of protein.
Nutrient-rich treated sewage not used for fish farming goes to irrigate the desert. Low rainfall here has driven some people to water their crops with untreated sewage. But around the treatment ponds, there is now a much healthier alternative. Treated sewage wastewater was used to raise this corn crop. It will support a cattle herd which provides food and brings in cash. For the local people, the treatment ponds are a success on several levels. First, they provide an essential service for safeguarding health. Second, by reducing pollution of the Pacific, locally caught seafood is safer to eat. Above all, waste has become a resource. But in spite of such advantages, this system has not been widely adopted. There is suspicion of low-tech methods the world over. This is Arcata in California. Suspicion of low-tech is as strong in the United States as anywhere. But in this town, alternatives are a way of life.
Good morning, Arcata! Welcome to Flush with Pride here on Waterfront Days. Hope you enjoy the great weather and all the good times.
15 years ago, when strict clean water laws came out, Arcata was cited as a polluter of Humboldt Bay. The state encouraged participation in a regional high-tech treatment scheme. Something had to be done, not least to protect the area's valuable oysters. But Arcata was concerned about expense and disruption. Today, the solution can be seen in 94 acres of newly created wetlands that lie between the town and the bay. These marshes provide low-tech sewage treatment so effective and popular that people here say they flush with pride. Like Peru, it's brought many benefits. Bob Gerhardt helped design the system.
The area that we're standing on right now was an open dump that received all of the county solid waste for a period of about 10 years, up until 1973. At that time, it was closed out by taking muds from the bay and putting it on top, and it's caused this elevated platform that we're on, which we refer to as Mount Trishmore.
Treatment begins at the edge of the marsh. In a perfect illustration of low-tech suspicion, state authorities required that primary treatment, settling and digesting solids, be done with this conventional equipment, although Bob Gerhardt insists the marshes could easily do the job. So the first unconventional stage is these oxidation ponds. As in Peru, they use algal growth to consume organic material and kill off pathogens. City engineer David Hull.
We take samples fairly often from all these ponds to see how the treatment process is going and make sure that we're achieving the standard we need to. This water then is as treated as the oxidation ponds will treat the wastewater. See, there's a lot of suspended solids in there, not much clarity at all.
Next, at the point where the Peruvian wastewater would feed fish and water crops, Arcata's marshes come into play.
First, the community of organisms that grow on the stems that are submerged in the marsh. There's bacteria and fungus and algae cells, things like that. They will actually grab onto suspended material as it moves through and acts as a physical filter. Another process that wetlands do for us to make the water cleaner is they have this ability to absorb nutrients. Now, nutrients such as nitrogen and phosphorus are essential to the plant's growth, and in fact, when they're absorbed in the plant tissue, they'll make it grow bigger and better. That's why people fertilize their lawns and stuff. But these nutrients, these same nutrients, had they not been taken out, can in some cases become a pollution problem.
As in Peru, marsh treatment needs several weeks, but the results are remarkably good.
This is below our standard, and so this would be adequate for discharge to the bay. There are times of the year that this is actually fairly clear. It almost looks like tap water coming out of here. It does vary seasonally, but as long as we can keep it below our discharge requirements, then it's a success.
Once through the marsh, the water is pumped into Humboldt Bay, where the oysters are thriving. The marsh itself has become an Audubon.
I'll stop there because I guess you had enough to answer your question, right? By the way, I know a biologist at that university whose grandparents died, left him a ton of money, and he bought a historic property right on that bird marsh. And like every day of his life, he just like watches birds all day, and it's pretty spectacular. I've gone there to visit him, and like, when nothing that you think of with wastewater has anything to do with that area. It's just like heaven. It's the most beautiful place. All right. Enough about that. Let's see if we can't do a little bit of progress on assignment 9.1. We have about 20 minutes. We should be able to get pretty far yet. 10.1? The one that we sent today. What is that? 10.1. First, the vocab. What is ore? Yeah.
Unrefined metals with impurities
that you can dig up from mines and
Yeah, that's it. Look, this is copper. If you could pass back some copper here. I mean, it's copper ore. As these are passed back to you, I think you'll notice right away those don't really have a lot of copper. Granted, the rock that Daniel is bogarting doesn't have a whole lot of copper because it's what we call low grade ore. High grade would have more copper, less rock. But keep in mind, a copper mine is not like digging through a gigantic glob of molten pennies.
That would be cool.
That would be rad. But I guess, like, obviously you did not expect that a gold mine is a cube of gold buried in sand.
Well, that's how it is in Minecraft.
Right, that's how it works in Minecraft. So, in other words, like, how does that actually work? You know, when you play the video games, it's just like, ding, and there's like a coin in the air. But these are kind of tricky processes. I want you to remember that basically any resource we get out of the ground is a stain on rock. It's like a subtle impurity. Really high grade copper ore, I believe, is about 10% copper by weight. That's like the good stuff. So you're still grinding up and heating or whatever you got to do, you know, like 9 units of rock for every 1 unit of copper in the absolute most glorious end of the spectrum. That's once you found the deposit. So first you got to move aside a whole bunch of dirt. That's just getting there. And then when you moved all the dirt, now you're there. You've reached the ore. 90% rock, 95% rock, 99% rock. And what is the RTC ratio? Will you take this to Paul Forster, please? What is the RTC ratio?
Oh, it's the amount of reserves compared to the amount of
Close. Yeah.
The amount of reserve compared to the rate of consumption.
Yeah. The amount of reserve compared to the rate of consumption. And this, what? Which room is Forster?
76.
76. I want everybody to know that in a really simplified system, the RTC ratio would work really well, but here comes a finer point. It's not exactly accurate. So let me give you a really easy example. My refrigerator holds 7 beers. That's the reserve. We know they're there. We know we can get them. There's 7. And I'm drinking 7 per day. How long will my reserve last? Okay. This is the basic concept. Because if I had 14 in the fridge and I'm drinking 7 per day, they would last me. Very good, everybody. And if I had 21, they would last me. But here's the problem. As those beers become more rare, I want to stretch out my beer consumption because each of those beers is now more valuable. So if I have 21, this is a pretty simple human behavior that I think most of you will probably understand. I might drink 7 today, and I might drink 7 tomorrow. But when I'm down to my last 7, I might just have 4 that day. And when I'm looking at those last 3, I might just have 2, but hold off with that last one. And when I get down to that last one, I might just sip on it and put it back in the fridge. Because God forbid, as things become more rare, they become more valuable, nobody wants to run out. So just so you all understand, the same way that you might stretch out your beer supply or your ice cream or your cookies or whatever other bad habits you have. This is like a crude approximation, but it's never a very safe prediction. Give me back my rock.
What's the blue stuff?
That's the copper. The blue stuff is the copper.
Oxidized copper is green.
Yeah,
It
it's
is
one of numerous possible copper oxides. The green stuff is also copper. Oh, by the way, that stuff is toxic, so you don't want to eat it. At that concentration, it's not going to hurt you.
You should tell me earlier.
God dang it.
So watch me. Obviously a mine. Obviously a mine. Not so obviously a mine. Something happened here, but I don't know what. What do you call that process of going from one use to a different use? I need to make a key distinction for you. This is a persistent misunderstanding. Students use the wrong lingo all year long. And even when I warn them, they still use the wrong lingo. So try to write this down. Restoration is to bring back ecological function. Reclamation is to prepare for a different use. Reclamation is about our use of the land, not about ecology's function in the land. So, you know, that could work as a parking lot. You could call that reclamation. At least, excuse me, spicy rice burrito. Oh, man. I was just thinking, dang, I wish my burrito was a little spicier. Have any of you heard of the ghost pepper? Yes. So one of my students makes me ghost pepper hot sauce, and I just poured the last of the bottle into my batch of burritos last night, and I think I just hit like a little pocket. Yeah. All right. Okay, so that's kind of reclamation. It's not a hole in the ground. And like, yeah, you know, there used to be a mine over there, but now we covered it up. That's good enough. You could probably build a stadium there, or a housing development. Or maybe this one, a park. Anybody know where that is? This is Ealing's Park. You can just barely see my house in this photograph, strangely enough. This has been a part of my slideshow before it was my house. I moved into this picture. My house is right under that tree.
I live really, really close to you.
That's creepy. Yeah, Connie Poniente, we talked about this because you found my baby head.
Yes.
Anyway, Cedar and I live right next to a place that used to have a different land use but has been reclaimed as a community park. Anybody know what that land use was? No. Back in the day, you used to drive up Valerio and down into the landfill where they would throw all their trash this way, filling in what used to be a canyon that fed into Arroyo Burro. And so they found a naturally low spot where there used to be like a canyon, and they just started filling it up with garbage, and then they scraped off some dirt from the ridge line and dumped it into that landfill. Then they would drive out and get back to Santa Barbara. But eventually people thought, having a landfill right in the middle of Santa Barbara, next to one of the busiest beaches, is probably not the right call. So we still have some of the worst water quality at a place called the Pit, because obviously we're draining a gigantic urban watershed that includes at the very last moment of the watershed, like literally in the last few yards of the water, an infusion of whatever the hell is seeping out of our 1940s trash. Have I told you that you should never smoke cigarettes here? A, you should never smoke. B, you should never do anything else that uses lighters. C, if you have these habits, don't take them to the softball fields because there's this thing called methane. Anaerobic decomposition of organic material underneath softball fields.
Has that ever happened to somebody before?
No, I've never heard of that, and technically I'm just kind of joking because the methane would probably dissipate at the Earth's surface. But I'd hate to be wrong. I see Bodie go up in smoke. So yeah, that place used to be a landfill.
Have you heard of Mount Trashmore in Virginia Beach?
No.
It's like a giant pile of trash that was then covered in grass and dirt, and they put like a skate park on the side of it too, and I went to the skate park when I was there.
No kidding. Wicked. It's. I want to remind everybody, this is not about getting the ecosystem to work right. It's about just trying to make use of things in a new manner. So a lot of waste areas are made into parks. It's like, why would we want to pay for it unless somebody can use it, but you don't want to leave it as raw garbage, and if the community's already covering it up, why not get a community usage out of it? They're usually managed by cities. Cities manage both the landfill and the parks, and so it's like a really common thing now to reclaim landfills as parks. Okay. So I want to skip number 10 and get going to number 11. We've got a bunch of stars here. Number 11 is like a really lengthy study goal.
Yeah, it is.
So, first, I'm hoping everybody understands these terms. Atmosphere, crust, upper mantle, lower mantle, outer core, and inner core. I think everybody's heard that the center of the Earth is liquid, like red hot metals. Some of you might know that the actual center nugget core of the Earth is actually solid because the pressure won't let it be a liquid. Yeah?
How big is that actual center core?
I don't know how to put that in context for you. Much larger than the moon, like absurd orders of magnitude larger than the moon. But I've never thought of how to make that into words that are useful. If it had land area, my hunch is it would be more the solid core or the full liquid core?
Solid.
My hunch is that it would have more land area than the United States, and I could be an order of magnitude off.
Could you compare it to another celestial body?
If I were smart enough, but I ain't. Yeah.
Yeah, like look to scale at all. That diagram.
Yeah, that diagram is actually pretty darn close to scale. And so you may also notice, speaking of that scale, that the atmosphere is really thin and the crust is really thin. And the magma is actually very thick. The scaling of magma to crust is similar to like a creme brulee with like that very, very thin solid glaze at the top. Creme brulee. I said it and then I look around and everybody's like, so sad, it's cool. Does anybody in Santa Barbara have a good creme brulee? Like, is there a restaurant that has?
I think what Fonz does. The White Beach. Yeah.
You leave me no choice. I know where I'm going after school. And now be careful, because the crust is not the same as the whole Earth, is not the same as the atmosphere, is not the same as the ocean, and you've got to know all of those. Get ready. In the Earth's crust, the crust, that's the little creme brulee hard part on top, you know, because it makes rocks when it cools off. The Earth's crust is about 45% oxygen, about 28% silicon, about 8% aluminum and 6 iron and 5 calcium. And you probably want to know the top 5 anyway. So oxygen 45-ish, silicon 27-ish, aluminum 8-ish, iron 6-ish, calcium 5-ish. There's like a little back and forth about how to get those numbers right.
What about like dirt? Dirt just all oxygen.
Dirt by elemental distribution as a global average is mostly oxygen. Yeah. Dirt in particular, like topsoil, like what you might consider loamy stuff, is mostly carbon. Yeah.
So you're saying like it's like solid oxygen, or like the oxygen in between?
No, it's like stuck to everything. So it's like famous people and blonde women. There's all sorts of famous people, but they all seem to prefer blonde women for some reason. So in the Earth's crust, there's all sorts of elements, but they're all bonded to oxygen. In the whole Earth, if we include the core, iron wins. The most common element in the solid Earth is iron. 1/3 of our planet solid is iron.
The actual solid core most iron.
And the actual solid core is almost entirely iron. Yeah, both the liquid and solid parts of the core are iron and nickel, and almost nothing else. 33% iron, 30% oxygen, 16% silicon, 14 magnesium, 2 nickel. And finally, in the ocean, which, in case you didn't know, is about 71% of the Earth's surface, you have about 3.5% dissolved solids. That's the salt of salt water. That's a surprisingly common bit of trivia. It comes up a lot, that the ocean is about 3.5% salt, dissolved solids. that's mostly chlorine. And the ocean also has like zinc and copper and tin and silver and gold, but in really low concentrations. Anybody know why it sucks to be a miner in the ocean?
Can't breathe.
Yeah, you can't breathe because you're underwater. And so the logistics of mining in the ocean are really overwhelming, even though there's a ton of potential down there. Actually, believe it or not, a lot of our resource problems would disappear if there was a rational way to get stuff out of the ocean bottom. If we could somehow afford to sift and filter and dredge and raise, we would like solve food crises, and like consumer products would be a lot cheaper. It's just getting the stuff out of the bottom of the ocean is obviously a logistical challenge. You can't breathe down there. What, bro?
You should just drain the ocean and mine it.
You know what's funny? Like, I don't think you were entirely serious, but there have been some shockingly large-scale projects to evaluate the possibility and potential of those. And keep in mind, if something gets expensive enough, that would make a lot of sense. If the price is right, you would do whatever it takes to get stuff. So right now, for like rare earth metals, people are talking about sending satellites that will re-aim comets to land them on the moon, so we can send a moon lander and ship material back to Earth from the crater.
That's expensive.
And everybody's like, obviously that's impossible. And there's somebody with a calculator like, yes, keep thinking that. And like they figured out, like, yes, it would cost me $1 trillion and I make $5 trillion. Evil genius. Okay.
Is it possible at all right now to get metals from the ocean?
Mechanically and logistically, it's pretty much possible to do anything. Yeah, right. It's just the cost-benefit question. And I want to keep going, but I think we're going to run out of time in a second. So tomorrow we'll go do geology and mining.